Hello everyone, I am Deniz Aydin and today I will be talking about my project Cool It. So this is the contents I will be talking about. First, I will start introducing Verai. It's a home between 2,500 people and 400 kilometers away from Darwin. And our site analysis found two compounding problems happening inside the same home. So the problems that selected is the heat and overcrowding. So for the heat, in most homes, there are no fans, no installations, and also because of the climate change, the degree is increasing year by year. And the second problem is overcrowding inside the rooms, homes. 15 to 20 people shares a single home, some of the seasons. And why this design matters? There are urgent design problems. The first one is electricity. People use prepaid power cards in there, so when the money runs out, there is power cuts off and they cannot use the cooling systems. And second is the sleep and privacy. Um, it can be disrupted sleep and also children can have lower school performance. And the third one is avoidance relationship, because of the red eye client groups require spatial separation. My selected research framework is low-tech, is local tradition ecological knowledge. So terracotta is a perfect low-tech material. It's been used for evaporative cooling for thousands of years across all around the world, especially in Australia, through Coolgardie Safe, which was itself inspired by Aboriginal water carrying technique. So Cool isn't importing a foreign technology into Wet-Eye, it's surviving something already embedded in indigenous knowledge. This is a theoretical frameworks, the culture fit design model. Well-being is supported when there's a good fit between architecture and its users. And I'm using SDG 1, no poverty, because the product must work without power. Modularity is that design can be adaptable into different spatial configurations. And also the co-design, the design itself should make with the community itself. And the precedents are terracotta block and terracotta valley event. They're using 3D printing techniques and also aerodynamical design forms for maximizing cooling services area. My materials are clay, as I mentioned, and steel. Steel is for the frames, especially for the separator. And the products can be done with the ceramic 3D printers. And the response is that will be community, there will be a community workshop that they can be learning how to do clay modeling. And also at the end, they can design the clay itself and then they can install to their homes for the especially for the separator. I've sketched some of models first, then I come with the product family that serves different functionalities. At the end, I've done the cylindrical forms with the three different products itself with the separators. So basically, Coolit is a passive cooling ecosystem, and each model serves a different purpose, but sharing the same evaporative cooling principle. First one is the water storage that can cool drinking water and keep them clean as well. For food cooler that can store fruit, vegetables, and the plant ecosystem, a planter is for producing the traditional plants. And the separator can be designed by the community itself. Each triangle can be different. They can do their designs on them, and then there are some frames they can put on it and create a separator. And these are the real life looks, renderings. And they can select which item they want. They don't need to get all modules. They can have the water tank with separator, separator with planter, all of them. It's up to the community itself. So material testing is for the real life. There are like different clay types, different firing methods, and also which form is the best. I've chosen cylindrical methods, and I've done air dry clay modeling. So at the end, uh, in conclusion, clay is actually a cheap material that doesn't cost a lot, and also production itself is also not that high. For installation, it's a tool-free installation. The panel frame goes in first, then the model sits on the base platform, and the low-tech framework. So cool. It uses a terracotta, evaporated cooling system, and community production, all of which are deeply rooted in indigenous Australian traditions. These are my references, and thank you for listening to me.